I was asked to come in and do a very short session, like a lot of the other sessions that you've had here. As you may know, there's a gift card drawing at the end. I believe it's a gift card, is that right? At the end, if you haven't put in your business card in the box, you want to do that. So what I'm going to do is I'm going to break down, make it really simple how AV goes over IP. So I have a longer session. This is part of a 1 hour and 15-minute long session that I've been doing around the country. Most recently I did it the Almo E4 AV Tour, and then it'll be in the E4 AV Tour this fall. But we're also going to record the next time I do this session, and if you watch the entire thing and take the 10-question test at the end, you get CTS credits for it. So this is a little snip out of that section. I'm with Rave Publications. We probably most known for going around this entire show floor and shooting videos at every single booth of every new product on the show floor. So if you're interested, you're welcome to take one of these cards. If you don't want it, you don't have to take it. This has information on how to subscribe to our publication. It's free. Or if you want to watch any of the videos that we're shooting here at the show, they're all in one, they're cataloged in one location. It's free. There's no advertising or anything like that in front of the video. It's literally just start watching the video. So ultimately, our industry is going through a big transition that we've never seen before, right? This has never happened in our industry before, where we've literally changed platforms, right? We certainly have changed the way we send signals. Back when I first got in the industry, we actually used all the signals coming out of computers were TTL. I don't know if you remember that, transistor logic, EGA and CGA. And then all of a sudden in 1988, IBM introduced the PS2 computer, which had that high density 15-pin VGA connector. That was the first analog output on a PC. So we've been in the analog world. We were in the analog world for almost 20 years, and then all of a sudden HDMI comes along and digital signal processing comes along. And we switched, for the most part, over to most of our devices being digital in one form or another. So we had a hybrid, and most of you have been integrating hybrid systems for a long time. We have some analog stuff, some digital stuff, and then ports that allow you to plug in or hybrid analog or digital stuff. We're quickly, and I mean quickly, moving to a world where we're going to go into a system or a platform, as I call it, that's got a lot of standards and protocols, which we've never had to deal with before. In fact, when I was at Extron, when I was a VP of Sales and Marketing at Extron, we made up terms for stuff because it didn't exist. We had to find ways to describe how things worked. What we're going to do as a platform, we're going to take all this data, all this color, all these bits, all these crystals, all these LCDs, all these individual bytes and bits of data, and we're going to cram them into a connector like this and send it wherever we want it to go, ultimately anywhere in the world. As we put it on the network, we will have the capability, as bandwidth increases, as we go into a 5G world, and as we go into a better Wi-Fi world, we're going to have the ability to not only take these systems and route them in a facility across the network. If I stand in front of you 10 years from now, and I'm still alive, what will end up happening is we'll send this content all around the world. I mean, literally, we'll have the bandwidth to do that. What that means is that, unlike any other time in the history of our industry, we're going to have to follow some standards and protocols to make sure that people, wherever they are, can pick up that signal and be able to see it and be able to manipulate it and control it and do whatever else they want to do with it. So this is not going to be an easy process. And you're going to be met with choices. There's a lot of different ways that you can actually do this. There's not just one sort of standard way to actually do this. So you're going to have some choices that you're going to have to make. And ultimately, you're going to have to educate your customer on what those choices are, because you're going to have to make trade-offs. There's going to be cases where you're going to have to decide, do I go this way or do I go this way? Because there's not just one way of doing everything. And by the way, this isn't just video we're talking about. We're mostly focused on the video, obviously, because the video is the hard stuff to do, right? Audio is not much bandwidth, control's not much bandwidth. Ethernet, ultimately, most of us are just doing email. Most of us are just processing Word documents and things like that. It's the video that's the critical thing. So we've had networked audio for the most part in our industry for about 10 years, and certainly the last 3 years, we've pretty much standardized on one format of networked audio, being Dante, right? AVB's out there, but there's only a handful of manufacturers that build AVB-based products, right, in audio world. But in the Dante world, there's something like 400 different companies building products that connect to the Dante network, and there's something in the range of a couple of thousand products that have shipped that are Dante enabled. And by the way, I don't know if you know this, but just the announcement a couple of days ago, Dante works on the SDVoE Alliance standard. So now anything Dante will run across SDVoE. That's substantial because now you've added another couple of thousand products, a couple hundred manufacturers, a few hundred manufacturers that plug into the SDVoE standard. So we're not just talking about video, we're talking about managing all of this. Now in the case of audio control and Ethernet, we sort of have a standard there, IP-based standard. Video, we don't really have that yet. So we're going to ride on this network, and we're going to hope that we make some good decisions in doing so. Excuse me. So you're going to have some decisions and some choices to make. And we have different flavors of switches, right? The network, the backbone of the network right now, for the most part, in any business, in any school, any organization you're going to do AV integration for is going to have something in that range. There's going to be some bandwidth capability or limitations in the network. What's nice about this is the cost to upgrade networks has come down considerably in the last 3 years, so we're finding that more and more organizations are rapidly upgrading their networks. We also see that the network companies have finally recognized that the AV industry exists. We have one sitting here in the booth, Netgear, that probably 4 or 5 years ago didn't even care or pay attention to the AV world because we were sort of riding on this other platform that they didn't have to worry about. And we even now have Cisco and companies like that recognizing and the fact that we're putting video on a network through video conferencing and sorry, not just through video conferencing. So we're going to have some decisions to make, but ultimately we're going to take and we're going to have to adopt what we're doing to what they're doing. So we're going to come into a customer's location and we're going to have to evaluate what do they have the capability of doing and what's their upgrade path for the current generation of their network. And that's really important because whatever you put in, you want it to be future-proof. None of us like putting in a system, 6 months later the customer find out there's a better system out there. So we want to educate the customer on how to be future-proof. Well, right now the future is 4K. And it's not really as much of a future as it is now. If you walk around the show floor, you'll see that nearly every manufacturer on the show floor is either launching or shipping 4K products, signal routing and distribution, projection products, display products, camera products, or 4K. So what I wanted you to do is I want you to live in an imaginary world for the next 3 slides because I'm going to try to break down how important this is that you pick the right system for sending AV over IP. In the case of 4K, we're talking about 8.2 million pixels. And we kind of throw this around in the world of, 2 megapixel, 4 megapixel, 6 megapixel, and so on and so forth. But this is a big deal. Why? Because the image is made up of a bunch of pixels. Who can tell me how we make white? You met that white that's on the screen there. How do I make that white? Who remembers from the old projection days, the CTS days? How do I make white? 100% red, 100% green, 100% blue. How do I make the black and the gigabit per second? How do I make the black? 0. 0% red, 0% green. So if white's 100% red, 100% green, 100% blue, and black is 0% red, 0% green, 0%, how do I make color? It's a variation of everything black and white. I just manipulate my intensity, right, and how quickly I turn things on and off to make all my colors. So all my colors determined by the intensity of each color and how quickly I turn it on and off. That's literally it. It's a bunch of ones and zeros. So we got to make sure that all that information, if it's starting out at 8.2 million pixels, each one of those has information on it. Each pixel is being addressed individually, digitally, to be told what shade I'm supposed to be, meaning am I red, green, or blue? What color am I supposed to be? And what shade of red, green, and blue am I supposed to be? Am I supposed to turn on and off fast, or am I supposed to turn on and off slowly? If I turn on and off fast, I'm going to be brighter than if I turn on and off slowly, right? So that makes a big deal. So we want to make sure that those 8.2 million pixels get to the other end as intact as possible so we're able to give that information to the other end. So here's what happens. Ultimately, the network can't handle uncompressed, completely uncompressed 4K in the real world today. Like, perfect scenario, yes, we would have uncompressed video, but we know that that doesn't exist today. We're going to have to do some compression. When we go to 10 gigabits, those boxes, let me back up one screen real quick. I forgot to mention to you. So I want you to pretend, and I hate standing in front of speakers, so I'm going to go down, okay, here. I want you to pretend that this represents 8.2 million pixels. So when I send those 8.2 million pixels across a 10 gig network, this is what I'm doing. What's nice about it, though, is because as long as I keep it divisible logically, it makes it easy to compress. So if I had the highest bandwidth, right, highest resolution, highest color bit of 4K I could possibly have, I'm going to be at like something in the range of 40 gigabits, okay? So therefore, if I take that and I compress it down to 10 gigabits, I've got a perfect 4:1 ratio. It makes it easy to do. But let me tell you what happens. So you have H.264, you have 1 gig and 10 gig options out there. That same set of purple boxes, when I go to 1 gigabit, this is what I'm doing. I'm going to one box. Oops. Let me go back. My clicker beat me to the punch there. So when I go, all those purple boxes that we had at 4 megabit, or at 4K, right, full bandwidth, this is what happens when I go to 1. So when you go from this to this, you have to be giving up something. Ultimately, no matter what we do in today's world, we're going to be doing some level of compression. And compression's not a problem. We've seen amazing compression. We've seen bad video conferencing systems, and we've seen good video conferencing. The question is latency. And the question is tearing up the signal, right? Is keeping the quality of the signal. Because we've been compressing stuff for years and years and years. Compression isn't the big issue here. The big issue is how well we do it and how much we can stay away from doing odd, non-divisible numbers in a way. So I'm going to try to break it down in sort of the simplest form. So we're going to have compression. That's not the big issue. We're ultimately going to slice it up and send it as packets across the network like anything else is sent across the network. And we want to make sure to do it right that the inputs or gazentas, the on-ramps and the off-ramps are compatible with each other, right? And that they are reading data from each other so that we can rebuild the signal on the other end and have the best quality signal that we can possibly have. So how does this actually work? A lot of you know these terms and know this, obviously, logically. You hear this and reading all the stuff on the sdvoe.org website. By the way, SDVOE just has a whole new educational section on their website of a tremendous amount of education on how all this stuff works. So if you want to learn more in depth, obviously, that's one place to start. So how does this actually, for those of you who are really highly technical, you're going to hate me right now because I'm going to break down something and sort of destroy it in your mind for those of you who like detail. This video here is a 4K video shot of somebody jumping off of a cliff. It's 5 seconds long, right? And all you're doing is watching it played over and over and over again. So now I'm going to take that video. I'm going to break it into 3 seconds, right? So we saw a 5-second video, and now I broke it into 3 seconds. Ultimately, what I'm doing is shortening the length of that video. Now I'm going to take that same video, and I'm going to go to 1 second. Okay, so what happens in 1 second of video, right? Because 5 seconds, 3 seconds, 1 second. As I shorten the video, what ultimately is happening when I show you 1 second of video? What is in 1 second of video? We've been talking about, in our industry for years, 60 frames per second. What does that actually mean, and how does that actually work? So I took that 1 second of video and literally imported into Premiere, because this is the easiest way for me to show you what's actually happening. So you're actually seeing that 1 second of video play over and over and over again. If you look really carefully, that 1 second of video has 30 frames in it, right? So you've heard the term 1080, 30 frames per second, 4K, 30 frames per second. So we have 30 frames here, right? So what you're actually looking at is 30 separate images. So each second of video, even though you just watched 1 second of video, you saw 30 pictures in your mind that put it together as motion video. But those motion video are not, it's not actually moving, it's actually a bunch of still images put together, and your mind puts them together because it's happening too fast for the human eye to detect that it's individual pictures. Everybody understands that, right? This is sort of video 101, and you learn this as video 101. Okay, so what are we ultimately doing when we take that video and break it down into its individual components to send it across a network? And we've been doing this for years. How many of you have done video conferencing or have a video conferencing system or ever watched a video conference? Okay, what are we actually doing? Here's what's actually happening. when I send this video across a network, and usually I like to stand in front of the screen, so I'm going to get away from the speakers here so I don't blow your mind. Maybe I won't be able to do this. Can you hear that, or is it okay? It's okay? All right. Try not to move. So ultimately, what I'm going to do is break those individual frames, those individual images, and I want to send them across a network. What I do is I do something really cool. What I do is I create image frames and picture frames. So what I do is fill the screen with some of those 30 frames, and then let me continue this all the way across, and you'll ultimately see. Okay, so I can't send across a standard network, which most of you guys have in your house or your businesses, full frame, uncompressed video, right, into a PC or into some device that plays a Zoom video conference or something else like that without doing some level of compression or without some level of manipulation of the signal. So here's how this works. I don't send all 30 frames. I pick out 6 frames, and those are my markers. And then if my processing is good and if my bandwidth is good, I'm going to then calculate what happened between this frame and this frame to reproduce these frames, because I said this device started here, this person started here, and then went here. What changed in the image? I'm only going to process what changed in the image because I have my image frames and my picture frames there. I'm only going to process what changed. That's ultimately what compression is. That's what makes up compression. So I'm pulling out 2 different kinds of things here. Image frames. The image frame is the actual frame of video, reference video, and everything in between is known as a picture frame. The picture frames are automatically, through an algorithm, created based on each image frame. So what happened between this image frame and this image frame? The more image frames I have, the better the picture is on the other end. So the less compression I can do, the better off I am. It's just a simple 1 + 1 = 2. Do you understand what I'm saying? So if I compress my video too much, I'm going to be left with very few image frames and a whole bunch of picture frames. And instead of figuring out what happened between here and here, I'm going to be figuring out what happened between here and here. And summing that in the middle is going to be difficult to actually reproduce, and it's probably not going to be as accurate. That's where you get the noise on the other end. That's where you get the ghosting and the other weird anomalies with the signal. All right, so we're starting with image frames, and we fill in the details with picture frames. I'm sorry about the flashing. I'm not sure exactly what's causing that. Could be my computer. So if I take that 5 seconds of video at 1080p, right, and I have it as full uncompressed video, that's 80 megabit. That's an 80 megabit file. On the right is a 264 compressed version of that 1080 file, and it's exactly the same, meaning I haven't done anything other than just use H.264 compression. And the one on the left is uncompressed, the one on the right is compressed. The file size is only 5.8 meg, but it works perfectly from a calculation standpoint to give me pretty good, well-compressed, easy compressed video. And that's what happens when you see streaming of video conferencing. And this is how this works when you send video over the network. Now, again, we're stepping up to 4K, we're going to have to be more careful in compression, so we don't want to use so much compression. So in the case of video, if I'm sending video over the network, here's a video just taken off of CNBC or NBC, sorry. Notice that nothing in the background is changing, right? The background isn't changing. The background isn't moving. So I'm going to take all my compression and all my power in compression, and I'm going to focus on his head and not mess with any of the background stuff, right? Because the background's not moving. So I only do this processing, this image frame processing, on the things that change. The things that don't change, I don't have to worry about processing. That's what's cool about where we're going to go with AV over IP. Because we're in a world now where most of the kind of stuff that we're projecting, like PowerPoint presentations and keynote presentations and Word documents and collaboration, isn't changing very much. Most of it's still images, and that's not changing that much. So the compression part of it is really easy to do. But what I want to do is I don't want to do too much compression. And no matter how you slice it, when you start with 40 and you go to 10 and then you go to 1, there's got to be more compression in there. So it's a trade-off. You're ultimately going to have to make a decision based on what the customer's application is. And that's why the different standards so-called standards exist. So currently right now, SDVoE is the only 10 gig standard for routing video over IP. There's a lot of 1 gig stuff out there with JPEG 2000, and there's a lot of companies out there that do one gig. So you're going to have to, what I would recommend you do, if I were you, because you don't want to be the responsible for the customer not being happy with ultimately what you deliver to them, is I would demo it. Literally set it up and show them the difference and let them decide, because if you have a reference, then they'll see what they're missing. So they have to be able to decide, and you got to give them the power of the decision. We've never had to do this in the past. In the past, we've walked in and just hopefully had a relationship with our customer where we decide what we put in, but now the customer has to decide based on the application. You need to help them actually decide. And that's the reason why this is not a simple, we're just going to put everything on the network kind of thing. We're going to have to evaluate it based on the applications. And right now, the least compression that you can do, you can go uncompressed, but walk around the show floor and find anybody can send an uncompressed 4K signal more than 10 feet without sending it fiber, right? Or even then, sending it fiber without very expensive transmitters and receivers. So going IP is the best way to go, but we're ultimately going to have to decide which methodology we use. I believe SDVoE, they tell us that their standard is not only the least compression, which obviously you understand now is, but also is lossless video, right? And that's what we were talking about in the very beginning of this, is that it doesn't really matter how much compression that you do as long as the picture looks the same on the other end. So again, I would demo it for your customers and let them help you decide. Currently, there's about 40 manufacturers making SDVoE gear. I know they're represented around here. There's a good demo here where you can actually see. And this is the kind of side-by-side you should probably do, where you can see the original video source compared to the compressed SDVoE, compared to 1 gig and the H.264, and you can see the trade-offs, right? And so you can make the decision for yourself. So thank you very much for your time and attention here. Don't quite leave, because I believe they're going to draw for a $20 gift card, or are they doing it after the fact? All right, coming around right now to draw for a $20 gift card. And thanks for your time. Cool.